Making errors. Realize that a small p-value suggests that the alternative hypothesis is true, but does not guarantee it is true. We are using probability to make a judgment. A type 1 error consists of concluding that the alternative hypothesis is true when in fact the null hypothesis is really true. A type 2 error consists of concluding that the null hypothesis is true when in fact the alternative hypothesis is really true. We can examine each error and attempt to control how willing we are to commit each. Think in this manner. The willingness to commit a type 1 error is given by alpha, the level of significance of the test. The willingness to commit a type 2 error is given by beta. Another term is called the power of a test and is calculated as 1 minus beta. And this is the probability that a hypothesis test procedure will correctly reject the null hypothesis when that null hypothesis really is false. We will decide the seriousness of each error and then determine relative values for alpha and beta. So we'll decide which of the two we want to be larger or smaller. Example 1. Your face-to-face stat instructor needs to give quizzes, but you've had very few so far in the semester. You know there will be several over the next few weeks, but the exact days are not specified. You must decide whether you will have a quiz the next class period or not. You define the hypotheses in this way. The null hypothesis H0, there is not a quiz next class period in Stat 205. HA, the alternative hypothesis, there is a quiz next class period in Stat 205. A type 1 error would occur if you conclude there is a quiz next class period in Stat 205, but in fact there really is not a quiz next period. Consequences. Look at what you concluded. How would this impact your preparation for class? Now, if that was your preparation, what would happen when you actually showed up for the class? How much of a concern is this to you? And what would you set for the value of alpha? Now, because you think there will be a quiz, you study and practice. When you get to class, there's not a quiz. You might feel like you could have spent the time doing other homework or projects, but studying now keeps the material fresh in your mind and might lead to less study time needed in preparation for the next test. This is not an error that has real bad consequences, so the value of alpha can be large, maybe even around 10%. A type 2 error would occur if you conclude there is not a quiz next class period in Stat 205, but in fact there is a quiz next class period. Again, think about the consequences. Look at what you concluded. There's not a quiz. How would this impact your preparation for class? If that's how you prepared, what would happen when you showed up for class? And how much of a concern is this to you? What would you set for the value of beta to be? How does it compare to the value of alpha specifically? Because you don't think there will be a quiz, you don't study. You get to class and have a quiz. You may hurt your course grade or feel discouraged. You don't want this to happen, so you set beta to be small. At least set beta to be smaller than alpha, or equivalently alpha to be larger than beta. Example 2. You're hiking and come to an old rope bridge located 50 feet in the air. You must determine whether it is safe to cross. Use the given hypotheses. H0, the bridge is safe. H0, the bridge is not safe. A type 1 error occurs if you believe the bridge is not safe, but in fact, the bridge is safe. A consequence, because you think the bridge is not safe, you stop the hike. You don't cross it. Or you might miss a spectacular sight or you might try to find another way that actually turns out to be more dangerous, or maybe you take a path where there's poison oak or something. What about a type 2 error? A type 2 error occurs if you believe the bridge is safe, but in fact the bridge is not safe. Consequence: because you think the bridge is safe, you try to cross it, but then you slip and fall. You could be seriously injured or even killed. Because of the seriousness of each error, you should set alpha to be less than, greater than, or equal to beta. What do you think? Remember, alpha is how willing you are to make a type 1 error and live with these consequences. Beta is how willing you are to make a type 2 error and live with these consequences. In this case, you should set alpha to be more than beta, because missing a sight is not as bad as getting hurt. So you want beta to be small in this case. Example 3. Suppose a water bottling company examines the seal on the bottles as they are prepared for packaging. If more than 3% of the randomly selected bottles which are inspected have improper seals, the process is stopped and the machinery is inspected and adjusted. Use the following hypotheses. Under the null hypothesis, the process is assumed to not be working correctly. Under the alternative, the process is considered to be working correctly. A type 1 error occurs if you believe the process is working correctly, but the truth is that the process is not working correctly. As a consequence, you don't shut the process down to adjust the machines. You have products with improper seals going to market. This could make people sick, the company may get a bad reputation, or even have legal action and get sued. There's likely a large loss of at least potential revenue. A type 2 error occurs if you believe the process is not working correctly, but the truth is the process really is working correctly. A consequence might be, since you think the process is not working, you shut down and try to adjust the machinery. It really might not have been necessary and you lose some efficiency. This might lead to some loss of revenue for the company as you're not maximizing profit. But you don't get sued and you don't lose your reputation. As a matter of fact, you may even get a better reputation because you're extra careful. So this error really is not as bad. In this case, what you would want to do, because of the seriousness of each error, is what? Would you set alpha to be greater than beta? That would mean you are more willing to make a type 1 error and live with the consequences. Is that really what you want to do? Not really. You want alpha to be less than beta because you want to guard against making a type 1 error. You don't want to make that type of mistake. So these are 3 examples of making and living with type 1 and type 2 errors and setting the relative level of comfort with making those, so you can see how alpha and beta sort of play against each other.